In this video, we are going to learn the concepts of engineering mechanics. One of the important terms we are going to use in engineering mechanics is force. So first we will define the term force, then we will know how to get the components of any force along any given direction. So the definition of the force is like this. Force is the action of a body on another. For example, if you are sitting on a chair, then your weight is acting on the chair. Let us say your weight is W, so W acts on the chair. So that means W is acting on the chair. So this is the action of the person sitting on the chair to the chair. Similarly, the chair can also exert a force onto the person sitting on it. So let us say, let's call that as R. And of course later we are going to show that this W will be equal to R according to Newton's third law. Now, force is actually a vector. So any vector will have magnitude, direction, and this force will have also line of action. For example, so here if you look, there is a force F acting on a body. So its magnitude is 200 Newton. This 200 Newton you can indicate with the help of the length of the vector. For example, if the vector is something like this, it may be 200 Newton. For example, vector is length, half of that it will be 100 Newton. If double the length, it will be 400 Newton. Like this, we can show the length of the vector to represent the magnitude of the force. Now, so that is about the magnitude. Then direction. This force here is acting from left to right. So the force can be acting from right to left, or down to up, or at some angle with the horizontal. So let us say it may be acting something like that, which makes some angle with the horizontal, some theta. So like this force vector can have direction. Now, in addition to these two characters, force can also have a line of action. So what is that line of action? So if you draw a line along the direction of the force, like this blue line here, this is called line of action. Okay. Now, this is another example of how the force can be defined. So this is a force. If a body is resting on a surface, so body will apply its weight onto the surface, whereas the surface will apply a reaction force on the body. Okay. Next, one more important concept we are going to use in engineering mechanics is the concept of rigid body. So rigid body is a fixed amount of matter. So some matter whose amount is fixed. Let us say the body shown here may have some 100 kilogram weight. So it is fixed. Then the rigid body whose parts are fixed in position. That means, for example, here point A and B can be joined using a straight line. The length of the straight line always remains constant. So that is, the distance between any 2 points A and B is always same. Then only it will be called as a rigid body. So rigid body we are going to use extensively in the engineering mechanics. In other words, the shape of the body will not change. Shape does not change. So this is another definition of the rigid body. When we are applying forces onto the rigid body, these forces can be applied along the line of action onto the rigid body anywhere. So this particular principle is called principle of transmissibility. So what is the principle of transmissibility? For example, here the force F is acting at point A. Similarly, same force is acting at point B. Similarly, same force is acting at point C. So the principle of transmissibility of a force system tells us that force can be applied on the rigid body anywhere along its line of action to produce same external effect. That means if force F is applied at point A or at point B or at point C, it will have same external effect on body that rigid body considered. Okay, so that is the principle of transmissibility. So that means here we don't bother about what is happening to the body internally. For example, here if force F is acting at point A, a little part around this point may be subjected to compression. Whereas if you are applying force F at point C, a little part around this point C may be subjected to tension. So that's called internal effect. So in the definition of principle of transmissibility, we don't bother about the internal effect. So this is called internal effect. Okay, next. Now let us look at another important law that will be used in engineering mechanics, which is called parallelogram law. So what is this law? The diagonal of a parallelogram represents the resultant of any two forces taken as sides of the parallelogram. So here we have a parallelogram. One side of the parallelogram is F1, second side is F2. Then if you want to find out the resultant of these two forces F1 and F2, only thing is you finish the parallelogram. That means this F1 will be drawn here, this F2 will be drawn here. So we got a parallelogram, and then we can draw the diagonal of this parallelogram. So this diagonal length is F4. So this F is the resultant of these two forces. Okay. So F1, F2 are the forces, F is the resultant force. This is how the parallelogram law can be used to find out the resultant of any two forces. Next, there is one more law which is called triangle law. This triangle law also can be used to find out the resultant force of any two given forces. So what is that law? If two forces are represented by two free vectors. So very important term here, two free vectors. So that means F1 is a free vector, F2 is a free vector. When we say free vector, we can change the position of those vectors without changing the orientation. That means I can take F2, I can draw it somewhere here like this, exactly parallel to itself. I can draw F1, take it, and F1 can be drawn somewhere here like this. So free vector is nothing but a vector which can be moved in the space freely. Now, so if we consider two free vectors F1 and F2, then these are placed tip to tail. That means this is the tip of F1, tail of F1. Now we take F2 and add it to the tail of F2 is added to the tip of F1. Then this is the tip of F2. Then if you are adding these two vectors like this, obviously if you join now the tail of F1 and the tip of F2 with this blue vector here, that is vector F, and the vector F is the resultant force of these two, F1 and F2. That's how we can easily find out the resultant of any two given vectors using this triangle law. Part 2 of this video is available with the link given in the description below. For more such videos, like, share and subscribe to this channel. Thanks for watching.